This is section 5.4, page 2. And we're going on to explain more about what the geometric mean means. So, remember the geometric mean is b in this proportion here. So if we're going to find the geometric mean of 3 and 12, let's go ahead and put in the values. So we know that we're going to put 3 in for A. We don't know what the geometric mean is, so we'll leave that as B. And then the other number is 12. Okay? And then we're going to go ahead and solve this. So we're going to solve it by cross multiplying. So what do we get there? We get B times B is B squared. You know what? Let's keep that room for my picture. Let's go up here. So B times B is B squared. What does that equal? 3 times 12 is 36. All right? So B squared equals 36. We're going to take the square root of both sides, putting in that plus and minus. And we get that B equals plus and minus 6. Or in our case, we're just going to look at the number line here. We're going to talk about 6. So we're going to start off with 3 here. And we know that our answer is 6. Okay, so let's see. How do we get from 3 to 6? Well, from 3 to 6, it's 1, 2, 3 places if we're adding. And then to get to 12 here, we'd say 1. Oops, don't put an arrow on the end of that. We're not done with that. Okay, we'll just say. Okay, so if we're counting there, that didn't turn out very good. If we're counting there, we notice that here it's 3 and here it's 6, so it can't be an adding thing. So think about a different way to do it. How do we get from 3 to 6? Well, we can add 3 or we can multiply by 2. How do we get from 6 to 12? Well, we can add 6 or we can multiply by 2. So do you notice that you multiply by 2 here, multiply by 2 here? So let's circle these important numbers, okay? So what we're finding is the geometric mean is the middle, middle, when you are multiplying. Okay? All right, so let's go ahead and answer these questions, or first talk about the definition. AD, this segment here, and DB are called the segments of the hypotenuse. Notice this is the hypotenuse because it's across from the right angle. So we call these segments of the hypotenuse. So the next theorem says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments. Okay, so the length of the altitude, so here's the altitude of the hypotenuse of a right triangle, is the geometric mean. So this here, CD, is the geometric mean of the lengths of the segments of the hypotenuse. So here's one segment, AD, and the other segment, DB. So now we want to write the proportion. Well, the geometric mean goes in these positions, so we're going to put CD here, CD here. And then the other two go in the other positions, and it doesn't matter where they go. Now, note, all of these I did not put a bar over because each one of these we're talking about the measurement. We want the number here, all right? Let's use this theorem to do the next problem. It says that assume that AD is the geometric mean of BD and DC. Okay, so AD is the geometric mean of these in this triangle. And if find AD, if BD equals 6, this one is 6, and DC is 8. All right, well, if AD is the geometric mean, let's start by setting up the proportion. So AD, the geometric mean goes here and here, and then the other numbers go in the other places, so 6 and 8. All right, then we're going to go ahead and cross multiply to solve. So we're going to get, you might not like that AD. Before we cross multiply, let's go ahead and just put in an X for that. Okay, and then cross multiply. Okay, so we're going to get X times X is X squared. 6 times 8 is 48. Okay, then we're going to take the square root of both sides. putting in that plus and minus, but because we're dealing with a triangle, we know that we're going to just drop the negative answer. So what is x? X is equal to the square root of 48. Or, what were we finding? AD. So let's go ahead and put in AD equals the square root of 48. Okay, for those of you, let's go ahead and circle the answer here. For those of you who know something about radicals, you know there's a perfect square in there. So we don't want to leave that answer. So instead, if you know square roots, okay, we're going to keep going with this. The perfect square in 48 is 16. So we would write this as the square root of 16 times 3. And then our square root properties tell us that we can break that up into 2 square roots. And then we know that the square root of 16 is 4. So our answer would be 4 square root 3. Now, if you don't know, don't worry about it. Okay, you can leave either one of these answers. All right, one more problem here. Use theorem 5.4.2 to form a proportion in which SV is the geometric mean. Okay, so here is that altitude. Now you may want to temporarily turn this around and look at it. Look at it this way. Here's the hypotenuse. Here's the altitude, okay? So this altitude is the geometric mean between the two segments of the hypotenuse. So this piece and this piece. Okay, once you've got that figured out, then we can go ahead and turn it back around and answer the question. So we know that we're going to set up a proportion, and SV is the geometric mean, so it goes here and here. And then the segments of the hypotenuse, which are these two, go in the other places. So TV, we'll put that one here, and VR, we'll put that one here. And it really doesn't matter. You could have put VR here and TV here. That still would work. Okay, that's it for page 2. Go on to page 3.